So one other concept I want to ask you about is what are quantum entanglement, and by understanding this, like what is the significance of the application to how we live our life?
Believe it or not, I spent a lot of time on that little nifty problem that Einstein came up with called the EPR paradox, right? And I fell into the trap that Einstein set for Niels Bohr and thinking that entanglement meant that there was spooky action at a distance. And so for years, I tried to figure out a physical explanation for the spooky at a distance connection using mechanics. I wrote papers after paper after trying to explain how you could communicate through space. And I actually did come up with a method that would require true entanglement of the two particles or photons or electrons, whatever you want to use. And finally, one day I realized that was a trick, a trap by Einstein to confound and make Niels Bohr stumble in their debates about quantum mechanics. It can't be that those particles are communicating faster in light. So what I realized was when they're created, the two entangled particles, they just have like a bunch of settings, polarization, let's say. One is the opposite of the other. Well, what they do in the experiment is they make those photons pass through polarizers on the way to the detectors. What they don't realize is that they're strengthening the correlation between the one polarized this way and the one polarized the other way. So there's an incomplete understanding of using the system as it's set up is flawed. So what it's doing is tuning the particles so they have a higher than normal correlation, which they can match up with quantum mechanics equation, therefore saying somehow there is a faster than light communication, but not really. I love that explanation. Well, there's really no, but somehow one knows the other particle. When you read the one, the other one knows to switch to the polarization opposite. That's when you get bad explanations like that, there's something very wrong in their assumptions. So all I'm saying is the reason why it looks like there's an entanglement is that this guy over here got set when the photon was born in a double jump of an electron. The other one gets set in the other opposite polarity. They go out. There's a correlation there. There is. And as long as you don't mess with either one and switch the polarization, you can measure this one, and then the other one will be the opposite. Seems like they're communicating. They're not. It was already set ahead of time. And what they did by forcing these things in the apparatus through polarizers, they strengthen that because they say, hey, I'm going to turn this polarizer in this direction and this one, and then force them through. And then I'm going to measure them and see how many match. Well, whatever polarization that was at, that might not have been totally 90 degrees out. Well, it will be when it gets through the polarizers. So you get a higher than normal polarization, which makes you think or appear that there's some sort of spooky connection going on. Now, there's actually no spooky connection going on. It's the way we measure. And we're not fully aware that we're manipulated. Anytime you touch something or you affect it in any way with a polarizer or any other bouncing something off, you're changing that something you measure. So you're changing the statistical odds of what's going on. So they're just not up to speed. And, it could be debated for years, but it's really just there's a correlation at the beginning. And if you do something to strengthen it, which they did, you get higher than expected results, which seems like there's a connection going on, but there really isn't.